My name is Jose Francisco Abisambra. I'm an assistant professor at the Sanders Brown Center on Aging in the University of Kentucky. This is my lab, the Abisambra lab, and we focus on tauopathies, the most common of which is Alzheimer's disease. I was born in Miami, Florida, and I lived there till I was 6, and then I moved back to where my family's from in Colombia. I lived in 3 different cities on the Atlantic coast, the Pacific coast, and then in Bogota, which is really great because Colombia is such a varied country in climate and people and customs and food that I got to experience a whole lot of what my home country really was. And so Colombia, at the time especially, was going through a civil war. A lot of the resources were really being channeled towards fighting this war. So I came to the United States, took advantage of my dual citizenship. I established myself in Florida, went to St. Louis University where I finished my biology degree, got a master's degree at the University of South Florida, and then my PhD also at the University of South Florida. It was really curiosity, and that was really shaped then by my grandparents. On my mother's side, my grandfather was a noted psychiatrist in Colombia. He essentially pioneered psychoanalysis, and he was involved in politics, in languages, member of all the academies. On my father's side, my grandfather was a chemical engineer and also very curious. And so he gave me my first microscope when I was about 6 years old. It was one of those Fisher-Price microscopes in plastic, and I loved it. What really clicked was when I was in my second year of medical school and I started doing some histology and I found neurons. In the cheesiest way, neurons are the most beautiful cells in the universe. They are elongated, they have these processes, they're very unique, their functions are critical for everything that we do. And clearly I hold them in very high regard. And after that, I just wanted to know more about them. Right? So I was going through my master's degree, and I was about 3 o'clock in the morning, and I was looking at these immunofluorescent slides, lost complete track of time, and I had one of those eureka moments when I found something that nobody had ever seen before. They say that those moments come up maybe once or twice in your career, and it's really hard to describe how exciting that is. When I was getting my PhD, I had a rare opportunity to be involved with some of the memory screens with patients. And I got to see firsthand what an Alzheimer's patient looks like, how this Alzheimer's patient behaves, and how devastating it is for the family. So I went from the basic science on the bench to the impact it could have on society. And one of the things that I love the most is to be able to mentor. So I have a very young lab, and ultimately I recruit them based on one thing, which is the same thing that I grew up with, is curiosity. There's a lot of talent at UK. The students here are fantastic. And the most exciting thing at this stage, now that I've been here for 3 years, is to see these students formulate their own questions and find their own methods to answer these questions. Our main focus is tau. Tau is best known as a microtubule stabilizing protein, which is very important for neurons because it essentially forms the pillars onto which cargo is transported along this beautiful svelte cell. For some reason, tau falls off the microtubule and becomes pathological. It chokes the neuron. And this happens not only in Alzheimer's, but in other 20 known diseases. In studying tauopathies, including Alzheimer's disease, we hope to impact a population of more than 9 million people in the United States and more than 30 million people in the world. Speaking of Alzheimer's alone, by 2050, if we don't do anything to stop this, we're going to end up spending $1.2 trillion, which is 1/3 of the federal budget. There is no cure for Alzheimer's or any of these diseases. So we hope that by identifying novel therapeutic targets and being able to intervene to stop the process, we might be able to improve the quality of life of these people, have a social impact, have a health impact, and an impact on the economy. So our lab is in the Sanders Brown Center on Aging. This center has been a pivotal aspect of the university, partly because we have an Alzheimer's disease center designation. There are about 30 other institutions in the country that have this designation, and we are one of the few that have had the designation from the beginning of the program in 1985. And we have one of the best brain banks in the world here at the University of Kentucky. UK has a very particular characteristic that far exceeds most of the other places I've been to, and it's that sense of collaboration. It's a sense of community. This is the place where I've been able to find very easily collaborations with some of the best scientists in the world. The opportunities here, the talent here, and that nature of collaboration, of wanting to help each other is unique.